Hello to everyone. This is first challenge of August when I can publish because this is my data set. And this challenge deals with this processing of time domain data set for huge amount of data. I will use my data set. Here is 450 stations. And here is a problem in every time because pulsar shape covered first windows, and I need to remove it from next filtration and inversion because it's well not good to have such data. Anyway, I know this is a problem with data, and there is a lot of lines, and it's not easy to do it for every line. So I'll apply next trick. So I'll set just one line for all points. Now I have all my data in one line. It's projected to this line. First of all, I'm going to remove two negative extremes. And next, I'm going to remove 5 first windows. And finally, I will turn back to original layout. Okay, what about one station? Now I have a data without this problem with every time. And next of all, I'm going to do massive 3D filtration of data. It's going to be 3D. This is settings for horizontal smoothness ratio and for vertical. Vertical mean times domain. So, it's not so quick because it's a lot of stations inside the project. But it's ready. Now we can see original result plus filtered result. Let's check it for different station. It looks pretty good, but this data is pretty good. So, okay. And now I can choose start model for pseudo 3D inversion. I think that's enough. Settings. And now I can use this option. And I need to wait a little because 3D inversion, it's of course not 3D, there is nothing about 3D, it's just 3D smoothing, but it's involved in inversion, so all stations are inverted together, and it's constrained by a common smoothness operator. So after several iterations, because this is shouldn't be very long video. I'll show you results. And it's of course better to show the same workflow OMT because it's much faster. And anyway, have a little time. So all these smoothing options, filtering options is very recommended. It's not only for 3D case, but it can easily apply to 2D or 1D data. And this can give you sometimes brilliant results of processing because the data sometimes very noisy. Okay, we already have now one iteration results, but RMS error is not so good. Of course, after one iteration. Let's plot it. So green line here, it can have different color segment. So red one is a worst RMS error and green is okay. So let's wait maybe 2 more iterations because now currently it's really good misfit. Okay, I think it's enough. I pressed escape key to leave inversion. And now I see all this layered structure and RMS. It's maybe better this way. And now we have already inverted results for all stations. And next, what we can see is RL view options to build, for example, integral resistivity or some individual resistivity slices for some specified depths or for layer. So it can be, yeah, and we can see this XY cut and our line here, how it's look like this depth. Another way for visualization is 3D fence diagram. I suppose you already seen it. And where is result of inversion? Not bad. Also, it can be resistivity columns. In this way. Or it can be XY cutting planes. And it can be set it up in this small window. So it took uh, approximately 10 minutes for processing of this big data set, and you can try it by yourself. Thank you very much for your attention, and bye bye.